that more or less the scenario that presents itself in any crime scene will be more or less the same. So we were also discussing about why firearms are given that name. So there is a, a tiny fire that comes out of the barrel at the end of the muzzle end. Hence that they are called the firearms, because the fire is emanating at the end, so they are called firearms. So when it comes to the investigation of arson, we try to give it a definition that it is a willful malicious intention on the part of the perpetrator. So when we said the properties of not only others but also of their own property. So we said what are all the occasions where somebody can destroy or devastate their own properties. Also we said there are maybe one or two occasions where if some business is running into losses, or some recession is going on, or the market for a particular commodity has fallen drastically. Now in such cases, and if the business entity has already had a insurance tie-up with the insurance company, in such occasions we said now all of a sudden overnight they try to either remove the content of the godown, or substitute the existing material with some other inferior quality kind of a material, and set to fire, and then say that it's all accidental and everything is reduced to ashes. Now please, I'm a premium, I'm paying premium every periodically, so you please give me the insurance. So that way, or the other occasions maybe they try to hide some other illegal activity, maybe some death, they want to conceal the death of a person, or they want to some manipulation in some economic offences like scams and all. There are a lot of documents which say somebody is due some money, some scheme money, so they want to avoid that money. So they will ensure that specifically those floors where such documents are present, they will specifically be gutted, and the reason that they give is that it is accident and all. So in such cases, normally we see that the arson is being resorted to. Now the only problem that we can say that we encounter in most of the time is the vital evidences that will tell us that a fire has taken place, and this is probably the cause of the incident, or this is how the fire has propagated and all. So these clues, very vital clues, most of the time are completely deteriorated, or most of the time they are washed away or knocked off, and the reason is very simple, that the first priority for anybody, including the police officer, is to save lives and limbs and property, isn't it? So when it comes to life and property, and the evidence, they will give preference for the lives of the person. So that way, and if some property is going to be reduced to ashes, they say that their priority will be to to put off the fire and all. So in the process, the vital evidences that we look for to establish that the incident is an account of fire will be lost, more or less. So whatever is remaining, that residue, we may have to very carefully and very systematically look into, and then we have to establish the first. There are two aspects in any fire incidents, whether it be accidental, whether it be willful act. Then what we need to establish is two aspects. One is the origin of fire, the other one is cause of the fire. Now, in order to know that there is willful intention, so any person who is bent upon destroying the property, he will make sure 100% that his act should surely result in complete destruction of the property which he is aiming to destroy, isn't it? In that case, he will not weigh and measure and then say for this dimension, for this area of dimension of a building, I should only measure this much inflammable liquid and I should only pour this much. So he will make sure that enough of it will be carried with him in the can or in the container, and he will ensure that in multiple places he is going to sprinkle this inflammable, if at all, if the cause of fire is on account of an inflammable liquid, he will ensure that he will sprinkle in all the places, all probable places where he feels most of the ignitable material is present. So in all such areas he is going to sprinkle, and then he is going to leave a trail of this in all the rooms. For example, it is a residential dwelling. In all the rooms, living, kitchen, including everything he'll put. Or in a business entity also, he will ensure that wherever combustible material or wherever some inflammable materials are there, such places he'll choose. And he is going to sprinkle this kind of an inflammable liquid which he is carrying, and he is going to sprinkle that everywhere. And then simultaneously in all the places he is going to use some ignition mechanism, and he is going to ignite the liquid which is poured on the floor. Now the result is, whenever you investigate such cases, you will find multiple origins of fire. This is very, very important. It's a strongest indication. The presence of multiple origin of fire is a very strong indication that it could be, if not 100%, at least 90%, we can say it is an act of an arsonist. So this is also important. Now, in order to understand the elements of the fire, now we know that there is a, now they say tetrahedron elements are there. Now the present concept is not only tetrahedron, we have at least 5 elements. Chain reaction is also included. So definitely you should have a combustible material like fuel should be there, and to burn the fuel also you should have oxygen, enough oxygen, abundant oxygen in the air. Then some igniting mechanism, ignition should be there, either in the form of a candle or a matchbox, or some source of ignition should be there. Then ultimately they also, in order to ensure that the fire sustains, you should also have a chain reaction, chemical chain reaction, which is a very progressive reaction. Now we also know that these elements, we need to understand the physico-chemical properties of these elements of fire, so that we can thoroughly understand how these elements help in fire propagation, and then how fire, once it is set, how it is going to spread, what are all the areas where it is going to diffuse, and then what kind of patterns or manifestations the fire is going to leave on different materials that are present in the surrounding. On a wall, what pattern it is going to create.
Yes, ma'am.
So what we are trying to discuss is this multiple origin of fire is one important thing, and the other thing is that what manifestation this fire is going to, and what is the first item which caught fire, and how the progress of fire is taking place, and what kind of manifestations this fire is going to leave on the surroundings. For example, on walls it may leave a different pattern, on metallic objects that are present in the vicinity it may leave some other pattern, and soot patterns will be different, fire signatures will be there as evidences, and then you also see charring will be there on paint, and then on distempers and all, it is going to leave a different pattern. Now all these patterns will be there, but then why different patterns, and typical V-type pattern or inverted cone type patterns, why these patterns typically are formed? And in order to understand these patterns, it is mandatory on the part of the investigating officer that we need to understand now what are all the elements of fire which will behave in a different way. Now the oxygen, presence or absence of oxygen, its concentration in the atmosphere, because we all know that only out of the air 20-21% is only oxygen and remaining is hydrogen. Now we also should understand the properties of different inflammable liquids like flash point, and then the fire point, flash point, then smoldering, pyrolysis. These kind of definitions if we try to understand, then probably we will be able to understand the investigation of any fire in a better way. So if we don't understand certain terminology, certain technical words, though it may appear very little physics and all is involved, but then once you try to understand it in a simpler way, then probably you will try to appreciate the subject, and you will also be able to investigate a particular arson case in a proper way. Now we know that unlike any oxidation, as we have discussed, that fire is a resultant of an oxidation reduction, redox reaction, because in the same reaction you know that reduction and oxidation both are involved. Such reactions are called redox reactions. Now redox reactions are exothermic also in nature. Now when do you call a reaction as an exothermic reaction? What is an exothermic reaction? Yes, any answers? थोड़ा जोर से बोलिए. हेलो, yes, don't know the answer. The thing is, now they in an equation, I think equation, reactants and all, I think we have studied in lower classes only. So in a reaction, when you try to represent a chemical reaction, there are reactants on the one side and then products on the other side. Now in the case of fire, there should be one fuel. When fuel burns in right proportion, only then fire can occur, isn't it? Now in this case, reactant is fuel plus oxygen. So when both of them are in right proportion and when there is a suitable ignition process, only then the fire can set in, isn't it? Now in case if there is oxygen depletion in the atmosphere, in that case also you may not see the reaction being fruitful, you may not see any flame there, isn't it? Then otherwise, if the fuel is in too much excess, also there may not be any possibility of fire, because the reason is that irrespective of the state of the fuel, because fuels occur in different forms, different phases of the fuel. If you see, fuel can occur in solid form, it can be present in liquid form, or it can be there in gaseous form also, isn't it? So fuels can have different states, that is solid state, liquid state, then gaseous state. Now the problem with fire is that fire can happen or can take place only when there is a vapor pressure, vapor in sufficient amount that can be there, and when this vapor can mix with the oxygen in the air in the right proportion, so they are going to form what is known as explodable clouds. They are called explodable clouds. Now what is the meaning of explodable clouds? These clouds are ready to explode as and when there is a suitable ignition that is available externally. This is called pilot ignition source. Now if there is an external source of ignition, then if that is supplied, these clouds which are formed on account of the combination of right proportion of the fuel in the fuel vapor. Not all fuels can burn. See, for fuel to burn, it should be in the vapor form. It should be only in the vapor form. So vapor form, not only that is the requirement, but vapor concentration and the concentration of the oxygen should be in right proportion, a particular proportion. There should be a mixture of this. So when these two mix together in right proportion, they will form what are known as explodable clouds. These mixtures will result in explodable clouds. Matlab, they are now ready to explode at any moment. But when will they explode? Only when there is a suitable ignition for this that can be applied, that can be supplied to these clouds. Then simultaneously all the clouds which are formed in and around the area, they are going to explode immediately, simultaneously. That is what you need to understand. Now, as I said, fuel can be in different forms, but please tell me why a person, an arsonist whose intention is, willful intention is to set fire. Now, if he has to choose a fuel, what type of fuel is he going to choose? What type of fuel do you think he should use? And what should be the form of it? Am I clear about the question?
Easily available to inflammable.
No, with regard to state. State, I said 3 states a fuel can take its form. One is solid, second one is liquid, third one is gaseous, isn't it? And I also told you.
Liquid is available.
Huh?
Liquid is available. Liquid is available locally, so you prefer liquid.
Why not some solid? Why not solid?
Solid may not be that much convenient to.
Why not? Why not convenient? Liquid is.
Ignition point, high fire point.
High fire point. What do you mean? High fire point. What do you mean by that?
फायर पॉइंट मीन्स तो टेम्परेचर का वो पॉइंट जिसपे वो वेपर बन के सस्टेनेबल फायर को सस्टेन करता है बहुत.
हाँ, this is what is exactly, because now solids, the molecules in a solid are so compact, isn't it? To break the bonds between the molecules, it takes a lot of energy, isn't it? And solids cannot burn directly. In order to burn, what they have to do is they have to convert themselves into liquid. Liquid has to again convert itself into gas, and only when it can become a vapor, it can mix very easily with the air, and that can lead to the formation of an explodable cloud, isn't it? They can, so with suitable ignition they can burn, isn't it? They can generate fire, isn't it? Now, exothermic reaction is one where lot of heat is generated, and heat also at times associated with flames and all. So, the oxidation that happens in generation of fire is not only exothermic reaction, it is a very, very rapid reaction, and it follows the generation of lot of heat. This is what you need to understand. I mean, in order to differentiate a normal oxidation from the oxidation which is involved in the fire generation, if you have to understand. Now, let me tell you that any iron article, if you are going to keep it in a moist condition in air, what is the observation? What do you observe on iron? A piece of iron rod, if you keep it in a moist air, you will see some observation on the rod. What is it?
Rusting.
It will take, even rusting is a kind of a oxidation. Now, why it is called oxidation? Now the air, you know that 20% oxygen is there, so it will react with that oxygen and then convert itself into some oxide of the iron, which will have a red color, isn't it? Now it's a permanent reaction, and it is called a chemical reaction, isn't it? And it is also a kind of an oxidation. But then you don't see any generation of heat over there. Do you see any generation of heat or flame or fire?
No.
There will not be any of these kinds. The reason is that it is a very slow reaction, though it is also a kind of an oxidation reaction, but yet it is not that rapid, number one, and the solid is involved. Iron is a solid. So, one of the two things that are required for a fire, what are the two important things that are required? One is fuel, the other one is oxidant or oxidation reagent, isn't it? So, here most of the burns, the oxidizing agent is the oxygen itself that is available in the air, isn't it? So fuel plus oxygen with some ignition will give you the fire, isn't it? Now, if the fuel is in the form of a solid, then you see that the molecules are so compact and all, and it will take lot of time for itself unless the temperatures are so high. For a particular metal to melt, what will be the amount of heat that has to be supplied? It has to be enormous, isn't it? First it has to convert itself into the liquid form, and liquid form has to convert itself into the vapor form. So you may require lot of heat. Now no arsonist will prefer a charcoal or some kind of a solid fuel, because it takes lot of time for him to generate heat. So the arsonist's job is to do the job in a silent way and without being noticed by anybody in the quickest possible time. So these are the constraint on the part of the arsonist. So why any foolish arsonist will choose a solid? So he will only prefer to use either gaseous. So gaseous are very dangerous to handle. For example, hydrogen. Hydrogen is very, very dangerous because it is very, very combustible, highly combustible natured gas. So it will be dangerous. How will he carry? How will he transport? Isn't it? So keeping all these in mind, the most suitable fuel for any arsonist would be only the liquid. So liquid also, not all liquids are highly inflammable. So within a very low temperature, they should be able to generate lot of vapor. So only then it will be effective, isn't it? So for an arsonist even to choose a liquid, it should be inflammable liquid. What do you understand by inflammable versus non-inflammable? What is non-inflammable versus flammable? Inflammable. Inflammable fluids are those fluids which can easily evaporate, isn't it? Which can easily evaporate even at the room temperature also. They should be able to generate lot of vapor, isn't it? So vapor is the one which matters for us. When we talk of fire, vapor is important for us, isn't it? Now, when any liquid, if it can, in a given low temperature, if it can generate vapor in sufficient amount, then it will be able to give that much vapor within shortest time, and that vapor can in turn form, mix with oxygen and form a cloud, explodable cloud, and that facilitates fire whenever there is a suitable ignition source. Am I clear about this?
Yes, ma'am.
Now,
Yes.
this is what you need to understand. Now, you need to understand some concepts of physics about heat also. Heat. Now, how many forms the heat can transfer itself? Heat transfers from one matter to the other, isn't it? Heat you cannot just see, but you can only feel heat. With the temperature rise, you see heat also. But most of the time we use heat and temperature interchangeably. But then there is a difference in that, Now, because of temperature, heat is generated, isn't it? Because of heat, temperature, heat is generated. Now, heat also will have, it will travel from one object to the other by three means. There are three forms where heat can transfer itself. What are the three forms in which heat can transfer? Any idea? Any idea you have?
No, ma'am.
This is important because heat is also one element which we need to thoroughly understand about whenever we investigate fire. Now, heat can transfer from one object to the other in three different forms. Isn't it? Two C's and one R. You have to remember that as two C's and one R. What are the two C's? One is conduction. Are you getting now? One is conduction. What is the other one?
Yes.
What is the other one?
Convection. and radiation.
Radiation, good. So these are the three forms in which heat can transfer, isn't it? Now, what are the differences? When can you say that heat is being conducted in what matter, and convection happens in what matter, and radiation how it transfers? So these are very important for us. In order to understand a fire in a room or in a compartment, then not only the patterns of fire are important. Yes, somebody raised a hand and all. I could see raise of hand. Is it accidental that you pressed that, or you wanted to say something?
गजानन साहब, आपने हैंड रेज किया है?
Yes. I think by mistake, or he wanted to say something.
By mistake नहीं हुआ.
By mistake हो गया. ठीक है, ठीक है. See, this conduction, convection, radiation. These are very, very important terms when we want to understand. Now, whenever a room is in fire or fire room में आ गया, then or in a compartment में आ गया, how it is going to spread? Through heat, how it is going to spread to other rooms and all, we need to understand. Now, what is conduction? Conduction of heat, what do you understand by conduction of heat? In which matter it happens? How the transmission takes place? Any idea?
By direct contact, preferably to solid.
So, solid rod, for example, if you heat one end, you will see that the other end also getting a little hotter, isn't it? So, this will happen from one molecule to other. Heat in the molecules which compose the matter, the heat travels from one molecule to the other, and that is the reason why you see. So as long as that medium is there, you will see the heat, and as long as the source of heat is there, it will travel. And as you rightly said, this will happen in a solid. Now when we talk of convection, then what is the medium there?
Liquids.
So liquid is the medium in which you see there is a movement of the molecules. Here the molecules will move. Now the denser molecule will become lighter, isn't it? In order to become vapor, what is the difference? What is the arrangement of molecules in solid, liquid and gas, which we have discussed earlier class? In solid, the molecules are tightly bound together by strong forces, chemical bondings, and in liquid they are little loose, and vapor they are all the more loose. That means what? The vapor density. What is vapor density? The weight that a vapor can have is called the vapor density, isn't it? So the vapor density, when you heat the liquid, what will happen? Will it become denser or will it become lighter?
It becomes lighter.
So it becomes lighter. Whenever a thing becomes lighter, will it spread? Will it come to the floor, or will it try to hit the floor if floor is there? If roof is there. Or it tries to escape from the liquid, isn't it? It tries to escape from the liquid. So when you heat water in a beaker by means of a burner, what will happen? What is the observation you will see? At a particular temperature, for example, the boiling point of water. What is the boiling point of water?
100 degrees Celsius.
But then, what you need to understand is, a water at temperature 100 degrees and a vapor at 100 degrees centigrade, which one will cause more severity on the skin? Which one will create?
Vapor of 100 degrees.
It also has got, in addition, it has got the latent heat of vaporization. In addition, the vapor also, because it is in the form of a vapor, it has got additional thing attached to it, which is called the latent heat of vaporization. Now, it becomes lighter, and then it tries to raise, isn't it? A similar thing also can happen when we burn when something is burnt on the floor. Now, because of the effect of the fire, what will happen? Lot of gases hot gases they start emanating. So because gases are little lighter in weight, what do they do? What do they do? Because these gases are combustible gases. These are called combustible gases. And by nature, gases being lighter, they try to move upwards, isn't it? Light gases being lighter than the fuel from which they are coming, they will be lighter and they try to travel upwards. Let us say a room has got a wall, isn't it? The vertical wall is there, isn't it? Now, because of the vertical wall, because of the nature of the gases that emanate from the fire, which are lighter in nature, they try to travel upwards, isn't it? And there, once they touch the ceiling or the walls, it gets cooled, isn't it? Now, once it gets cooled, it will try to spread horizontally. It tries to spread horizontally. And that leaves a typical pattern called the inverted V. So, whenever you see the pattern and once it starts burning, the residue also it will leave. It will also leave the residue in the form of either the soot or the smoke, isn't it? Now the smoke likewise is going to leave a typical pattern, what is called a V pattern or inverted cone pattern. So whenever you find an inverted V, an inverted cone or V-shaped pattern of a smoke, the point where the V is the V is there, V formation is there on the floor, that is the point you have to understand as the point of origin of the fire. Am I clear about this? How to understand the point of origin in case of a fire? Then what you need to initially look for is, look for that V type of patterns. V patterns are otherwise, V patterns are formed on account of either soot or smoke. So smoke is going to leave a typical V form, otherwise it is also called as an inverted V form, isn't it? Now what does that indicate? The moment you locate this pattern, V pattern, then what should it imply? What is the clue that you are going to get out of that? The bottom of that V, the bottom of the V, if you see beneath that on the floor, that is most probably the point of origin of the fire. Am I clear about this? How will you establish the point of origin in case of a fire in a room? That is the question, suppose which is given, which you are asked. Then what is the first observation as a investigator, what you are supposed to do? Look for this typical pattern. What is the typical pattern? In a confined room or in a compartment, what is the typical pattern you are going to look for? What patterns the smoke is going to make?
V or inverted cone.
Inverted cone. Now how will you establish from that pattern the origin of fire? The pointed V, the bottom of V. So if you look near the floor, so whatever point that it is showing, indicating, that point in all probability is the point of origin. Am I clear about this? This is one pattern. Now there may be discoloration, and one more thing is, some of the gases, like if suppose enough oxygen is not there, not always we have enough oxygen availability in the air, isn't it? For some reason, if the ventilation is improper, if all the doors are closed and all, if all the windows are closed now, fire is happening, then that means you have sufficient fuel but then insufficient oxygen present over there. Now, whenever there is insufficient concentration of oxygen, that fire is going to lead to what is known as impartial or incomplete combustion. That means it's not going to convert itself into carbonaceous material or the end products, carbon dioxide and water. If they are the end products, then you say that there is complete combustion, isn't it? Now, because there is not sufficient oxygen in the air, now the combustion is not complete, or rather it is partial, are incomplete, the result is that it is going to generate some gases which are combustible at the same time and which are noxious, which are very toxic, What are some of the gases which are toxic, which get generated during fire investigation or during fire engulfment? What are the typical gases, toxic gases?
Carbon monoxide.
Yes, or कार्बन मोनोऑक्साइड के अलावा
NO2.
Not exactly. This is called hydrogen. Sulfur dioxide is also not that, it may be pungent but not that toxic. The most toxic one is the one which generates out of burning of plastics. प्लास्टिक जो होता है ना, वो बर्न होने से, एस्बेस्टस वगैरह वैसा चीज़ें बर्न होने से we get a gas what is known as hydrocyanic acid. HCN is its formula. So apart from carbon monoxide, we know anyway carbon monoxide is a toxic poison, but apart from carbon monoxide, there is also generation of what is known as hydrocyanic acid. HCN is its formula. That comes because of the burning of the plastic material. Now, why are these materials getting generated? Why toxic materials are getting generated? Otherwise, a full combustion, if it is a good fuel, full combustion, combustible material, if it is there, enough oxygen is there, then there is a complete combustion of the entire fuel, leaving no residue and all. But in normal life, in routine life, it never happens. It never happens. Now, most of the times it is only incomplete combustion. Now, incomplete combustion always leaves us with a lot of toxic gases, as I told you, depending upon what are all there inside the building. So, it may be a residential house at times, or it may be a business entity where textile business is going on, or dye manufacturing is going on, or some explosive materials are going to be manufactured, or some other business entity, commercial entity, where some business relating to these things are happening. So depending upon these things, you will get whether the fire is fast spreading, rapidly spreading, or whether it is slowly spreading and all. I mean, again depends what are all the materials that are there in the dwelling. Then I said these two gases are very toxic. Now, why the toxicity of carbon monoxide? Why HCN is so toxic? Why is carbon monoxide is so toxic? And at the same time, the other oxide of the carbon called the carbon dioxide is not harmful. Why only carbon monoxide is harmful? Why that is poisonous? Why carbon dioxide is relatively non-toxic? Because simultaneously forensic medicine, these and all I will be clubbing for your benefit, for better understanding, and they are all relevant. So there are two forms of oxides of carbon, isn't it? One is carbon monoxide, the other one is carbon dioxide. Carbon monoxide is CO, carbon dioxide is CO2. So same oxides of the same element, why one oxide is toxic, why the other oxide is not toxic? Any idea?
कार्बन मोनोऑक्साइड वो हीमोग्लोबिन को बाइंड कर देता।
यस, कार्बन डाइऑक्साइड
रिजल्ट बता रहा हूँ, टॉक्सिसिटी का मेन पर वो नहीं पता फंडा, लेकिन ये रिजल्ट
यही फंडा है. व्हाट यू आर सेइंग इज करेक्ट. टेल मी, दैट्स करेक्ट ओनली. टेल मी. हीमोग्लोबिन से क्या बनता?
कार्बोक्सी हीमोग्लोबिन.
The point is that whenever oxygen is there outside, when oxygen enters into lungs, it forms a kind of a very loose affinity, very loose bonding with the hemoglobin, so that when along with the oxygen, the hemoglobin will be carried to different parts, and where in the tissues it will dissociate, and the hemoglobin releases the oxygen to the tissue, so that the tissues are supplied with oxygen, is the fundamental thing. Now, in presence of carbon monoxide, what will happen? The carbon monoxide has got more affinity for hemoglobin than oxygen. Are you getting my point? The carbon monoxide has got more affinity when compared to oxygen. So when both of them are there available in the atmosphere, so oxygen is being replaced by carbon monoxide. Are you getting me? Oxygen, in the fighting that happens between carbon monoxide and oxygen को हटा के carbon monoxide will take its place. Now carbon monoxide and hemoglobin bond is not that loose. It will be so tight. Once it is formed, it is irreversible. It will not release carbon. It will not release hemoglobin freely. So whatever little hemoglobin that is there, it gets struck with bondage with carbon monoxide. And you will not get any hemoglobin at least to combine with the external oxygen. Oxygen is abundant outside, but then you are not able to avail that oxygen because your hemoglobin is tied up already with the carbon monoxide. So non-availability of hemoglobin, you are not able to utilize the oxygen. So hence carbon monoxide is called the competitive inhibitor for oxygen. It is called competitive inhibitor of oxygen. So that is the reason why if carbon monoxide is there in the air, that is more and more lethal. More and more lethal. And one more thing, why carbon dioxide is used in extinguishers is that carbon dioxide also can displace oxygen. But that is required to put out the fire. So you have to remove one of the elements. Either you have to remove the fuel, which is not possible, or else you may have to remove the oxygen, isn't it? To remove oxygen is easy, isn't it? So you use carbon dioxide, which is an extinguisher, fire extinguisher. So the property of carbon dioxide is to displace oxygen. But then in comparison, carbon dioxide is not that capable of displacing oxygen in comparison to carbon monoxide. Are you getting me? So carbon monoxide, that is the reason, is more lethal and toxic compared to carbon dioxide. So that is the reason why people die of suffocation when in a fire accident, if people are there, even in the low ground floor people, even if small fire is there, not very severe fire, but if all the ventilators are closed, if all the doors are closed, you will see people dying because of suffocation. Because insufficient oxygen is there, fuel is burning, so a lot of toxic gases are being generated, and the people are going to inhale all the oxygen and they are going to die of suffocation, is what you need to understand. Now, when talking about the three forms, conduction, then the convection, then your radiation. Now we have understood conduction, that happens in solids, convection happens in liquid form. Then when you talk of radiation, radiation of heat doesn't require any matter because it goes by electromagnetic radiation. It is electromagnetic radiation. Now it doesn't require any, it radiates, isn't it? It radiates. Now the conduction, when you talk of, heat will have only one motion, one movement, that is from the molecules which are there in the aligned in the solid, they will travel from one molecule to other, and as long as the medium is there, the heat will get transferred. In case of liquids, it is because of the movement of the molecules that are there in the liquid, it will happen. But in radiation, you don't require anything. Heat, it will just radiate in all directions, not only in one direction. So radiation heat will travel in all directions, unlike a conduction and convection. So these parameters are very, very important. Now you also need to distinguish between the glowing flame and flammable fire. Glowing fire and flammable fire. What are the difference? What is the difference between the two? That is, otherwise glowing fire is also otherwise called as smoldering. What is smoldering?
स्मॉल्टरिंग में मींस कि जब ऑक्सीजन नहीं है
हाँ.
तो वो पॉसिटी ऑफ ऑक्सीजन में जलता है, जैसे कि सपोज सिगरेट का बट
हाँ
बट पे जो जल रहा है वो
हाँ
स्मॉल्डरिंग इट्स काइंड ऑफ, और कोई लकड़ी है,
हाँ, कोल
चक्की है,
कोल भी
तो
है,
ऑक्सीजन
कोल,
कम
हाँ
होगी,
हाँ।
बाद
ऑक्सीजन
में वो
कम
हो
होने
सकता है।
से नहीं, वो नहीं। हाँ बोलिए। सी, दे आर ऑल
स्मॉल्डरिंग
सॉलिड्स।
बर्निंग।
सॉलिड है ना वो तो, सिगरेट भी सॉलिड है ना। आपका कोल जल रहा वो भी सॉलिड है ना। लकड़ी है वो भी सॉलिड है ना। These are all solids only. So solids, when there is a heat, when you have ignited that solid fuel, what will happen? If you ignite a solid fuel, what will happen? It has to become vapor first, isn't it? It has to become liquid vapor. Only then it can fire. But only if you see the surface of the solid fuel, the surface of the soil fluid, only that portion you see vapor formation, not the entire fuel. Are you getting me? Only the surface, if you observe, surface will have the vapor. Only that smoldering is a surface phenomena. It is a surface phenomena. You will see only glowing of the flame. You will never, glowing of fire. You don't see flame of a fire, isn't it? No, that is it is a surface phenomena. Whereas a flame fire is you will see that it is not a surface phenomenon. And you see that vapor is in sufficient quantity. In case of flame to happen, ignition, ignitable liquid hona hai, and it should be able to, at a given temperature, it should be able to generate enough of the vapor. Enough of the vapor. So that is one thing you have to understand. Now, what is, again, when we have understood this, now you should also understand in terms of a solid what is known as pyrolysis. What is pyrolysis?
सॉलिड का
हाँ,
डायरेक्ट चेंज इनटू गैस,
direct change into gas.
गैसियस स्टेट।
हाँ, not exactly. Not exactly. So pyrolysis means, now normally in presence of oxygen what will happen? So we have seen in domestic gas and all. So when you light your gas stove, what will happen? You get a blue flame, isn't it? You get a blue flame. So in case if you are getting some orangish flame, that is combustion is not proper. The fuel is not going to properly being utilized. So there is incomplete, there is some blockage. So burning is not complete, and you get some orange or red or different colors other than blue color, isn't it? Now, the thing is, in pyrolysis, oxidation chemical reaction will happen, but then because of heat, a bigger molecule like a polymer will be converted into its monomers. Polymer will get converted into monomer. For example, wood है, cellulose है wood में, है ना, lignin है, lignin है. These things are there in the wood, or paper, or cloth. So these are all called polymers. पॉलीमर में पॉलीथीन, पॉलिएस्टर, वो तो हमको पता है ना. वैसा ही इसमें भी पॉलीमर से बना है, कॉटन या पेपर या क्लॉथ. ये आइटम्स दे आर मेड ऑफ पॉलीमर्स. नाउ व्हाट विल हैपन इन pyrolysis? Because of heat, these big molecules, macromolecules or polymers, are converted into its simpler form, or small molecules. They are converted into smaller molecules without any reaction with oxygen. There will not be chemical reaction in the oxygen, but then they will be converted into smaller molecules. So this is called pyrolysis. Lysis means splitting. Lysis means splitting. Pyro means heat. So because of heat, these bigger molecules, so-called bigger molecules, which are composed, which are present in a solid, are converted into simpler molecules. So poly means many. Polymers are converted into monomers. That means its individual constituents, they will be divided. So that is an account of the heat. Hence the name pyrolysis. And all solids are subjected to pyrolysis. Examples are wood, charcoal, paper, isn't it? So they can be converted into the they can be subjected to what is known as pyrolysis. I hope I am clear. Am I clear, or
Yes,
you are getting more and more confused?
No, I'm clear. It is clear.
Today there is no response from Gajanan. You are able to understand Gajanan, or is it becoming too Greek and Latin?
Yes, ma'am. Yes, ma'am.
So because these are important in order to understand, there is nothing, fire investigation nothing but what are the effects of this fire on different surroundings, and then why these manifestations are happening, what is happening to the ignitable liquid, and how it is converting itself into vapor, and what is the what is the repercussion of this vapor on the surroundings, and all these are all the things we need to understand. So if we don't understand the basics fundamentals, you will not be able to appreciate the investigation part of it. So that's the reason, though it is little technical and all, I am trying to explain these things in a very clear manner. Now, and to understand what are the common fuels to produce flaming combustion, can you say? There are also some fuels which can create the flaming combustion. So we have seen two types of combustion here. One is smoldering, that is called glowing combustion. The other one is called the flaming combustion. So what is the difference between the two? Glowing combustion, then flaming combustion.
Glowing combustion is surface combustion. Uh,
Flaming combustion is?
happens in solids.
And what is the reaction rates? Which one is faster, which one is slower?
The glowing combustion is slower.
It is slow. It will be good if somebody wants to cook a fish, if somebody wants to cook some non-veg, it's okay, isn't it? No, it doesn't lead to disasters. But then, whereas a flaming combustion will be devastating, isn't it? So the reason is that glowing combustion is a little slow reaction compared to the flaming combustion, isn't it? So if we have to name few common fuels that produce flaming combustion, we can talk of gases, we can talk of some liquids, and these are some of the, even solids, if you heat to a very great extent, then probably they may convert into the flaming combustion. Now, flaming combustion, what is that you have to understand? In a flaming type of a combustion, both fuel as well oxygen, both of them have to be in the gaseous form. Only then the reaction will be rapid. Now, in flaming combustion, why flame is coming? For flame or for fire, what are the two ingredients that are required? One is fuel, that we have understood. Another is oxygen, that also we have understood. Oxygen anyway, every time it will be in the gaseous form only. We need not take trouble to make it remain in the gaseous form. What is the other one that we have to keep in gaseous form? Fuel has to be in gaseous form. But we know that not all fuels are in gaseous forms, isn't it? There are solid fuels also, there are liquid fuels also, there are gaseous fuels also. But the flame to be effective, the combustion to be in the form of a flaming combustion, what is required? Both the fuel and the oxidizing agent both of them should be in the gaseous form only. Only then you see the flaming combustion, isn't it? So that means what? Both fuel and oxygen, they have to be in the gaseous phase only. Now, certain fuels, they already exist in gaseous form. There is no problem. Like natural gas, our domestic gas, whatever, that is, they are already in gaseous form at the room temperature. No issue. The fuels are already in the gaseous form. Now, immediately, therefore, they are suitable for forming a flammable combustion. Are you getting me? Now, I told you also, hydrogen is little dangerous. Hydrogen is dangerous. Though it has got very good properties, like it can burn very readily, rapidly, and then it can generate very, very hot flames, and it is easy to ignite, and despite an environment friendly also, unlike carbon monoxide and all, this is very environment friendly. But still, but still. And one more advantage is that the combustion products, like in carbon, if sufficient oxygen is not there, we have the problem of carbon monoxide, isn't it, combustion product. But unlike that, hydrogen combustion product is only water, that is water vapor. So water vapor is not at all harmful. So why not we take hydrogen as the fuel? Hydrogen is anyway gaseous form, we need not take trouble to convert it into gas, already it is existing in gaseous form only. But then it is also has got good qualities, like it can burn very rapidly, it gives very very hot flames, very easy to ignite, isn't it? And it is also environment friendly. What do you understand by environment friendly? What do you understand by environment friendly?
leaving less residues and non-polluting dust.
हाँ, नॉन पोल्यूटिंग का मतलब इसका एंड प्रोडक्ट वो बर्न होने के बाद जो प्रोडक्ट मिलता ना, वो तो वाटर वेपर होता ना, H प्लस O2 इज इक्वल टू H2O होता ना, वाटर होता ना, वो तो एनवायरमेंट फ्रेंडली है, वो तो वाटर वेपर है, इससे कोई हानि नहीं है ना एनवायरमेंट के लिए. तो इन ऑल aspects, hydrogen should be a very suitable kind of a fuel. Why are we not using hydrogen? That is the problem. Why are we not using? Now, the only problem with hydrogen is it is not at all safe to store or either to transport. This is the only trouble with hydrogen. Otherwise, as a fuel, it has got all good qualities. Now, some common gas fuels, what is that you can understand? One is your natural gas, isn't it? Natural gas, or the gas that we use for domestic purposes. Most of it is, what is the composition of the normal domestic gas? What is the predominant gas present over there?
Methane.
Methane is the gas. So at room temperature, no issue. Even if you burn it, does it violently burn, or what kind of flame you get? If you light your gas stove, what will be the color of the flame? Is it red or blue?
Yellow.
Blue. Yellow or orange, you should suspect some foul play, or you should suspect some danger. Either it must be कीड़े वीड़े आते ना, उसमें घुस जाते, small insects that they keep coming in the kitchen, either they are blocking your burner or your regulator, or that is the reason why the fuel that is coming out from the burner, it is not coming out fully. Half of it is coming and half of it you are getting a smell, it is not getting burnt, isn't it? So that is the reason why you get a red flame. So red flame or pink flame, any other flame, you should understand that it is incomplete combustion. Blue wala flame jo hota hai, complete burning, it doesn't leave any residues and all. So it's a complete combustion kind of a thing. Now, so that is the reason why we don't use hydrogen, है ना? हाइड्रोजन का क्या प्रॉपर्टीज, अच्छा प्रॉपर्टी के अलावा भी इसको हम फ्यूल जैसा यूज नहीं कर सकते. The reason is that for transporting or for using it, there is a lot of issue in that, it is a little dangerous and all. So otherwise it has got a very good properties of the fuel. Now fuel oils, and then some ethyl alcohol kind of a thing, and kerosene and all, they also have a lot of volatile materials in it, and then they also will result in flaming combustion. So coal is one exception, you can get only smoldering kind of a glow combustion only there. Now, as I said, many polymeric molecules such as plastics will also burn. Now, what is the problem with that? Why are they not? The polymeric molecules, I told you all, polythene, polystyrene, है ना, ये सब. उसमें one of them is also plastic, but then plastic also can burn. Why are we not using that as a fuel? Why is it not being used as a commercial fuel?
Releasing the toxic.
They release lot of this hydrogen cyanide kind of a thing, and then a lot of HC and carbon monoxide. So they are rich in this, and then their products, the end products are very very toxic to life. So most of them are asphyxiating type of gases, Hence, we don't prefer using plastic as one of the fuel. Now, the commercial fuels, what should be when they burn? What are the end products? Like methane, for example. Methane is the normal domestic kind of a gas. Now, when that is, and most of the time is the commercial fuel that we know. Now, why is it called as a safe fuel? Why are we using that as a commercial fuel in place of hydrogen? Hydrogen, we have understood why it should not be used. But then, what is the advantage of using methane or any other commercial fuel as one of the fuels? What is the advantage? In what way are they safe? What element is making them safe?
Storage.
Storage is one thing, okay, but then other when you try to compare hydrogen versus the commercial fuel, what advantage these will have, commercial fuels will have? Are they environmental friendly or not? For example, methane. For example, methane is a commercial fuel, है ना? So methane will react with oxygen, है ना? CH4 plus O2. अब एंड प्रोडक्ट कौन सा हो सकता है? Methane is a combustible kind of a gas, ignitable gas, isn't it? So when it reacts with oxygen in the air, it will form carbon dioxide and water. So both are environment friendly only, unlike carbon monoxide, isn't it? Carbon monoxide is the end product of plastic combustion, isn't it? But whereas commercial fuel, why are they popular? Because they are environmental friendly. The end products of their fire, their combustion is eco-friendly. That means the end products are carbon dioxide and water. Water is a vapor, no problem. Carbon dioxide is lighter when compared to carbon monoxide. ठीक है, carbon dioxide इतना तो toxic नहीं है. So end products are non-toxic, easily ignitable. इसीलिए they are called as commercial fuels, very good commercial fuels. Now, common solid fuel, if you want to name, what is the fuel that you can name? चारकोल है, हमारा कोल है ना, ये सब तो वुड भी है. These are all solid fuels. Now, slowly heated and burned in oxygen deficient atmosphere, charcoal will not vaporize, isn't it? Does it vaporize initially? It only burns slowly, isn't it? It is going to blow, it is going to burn very slowly, and it is a surface phenomena, I told you, and it gives, and we said oxygen is not that much, Now, what will it give? It is going to, since it is only a surface phenomena, it is going to give us the glowing kind of a combustion, isn't it? But even if there is heat also, but it will not give you the flame. That is one point in smoldering you have to understand. Now, so when you want to understand the combustibility of a fuel, that is one of the chief characters of the fuel, combustibility is an important thing. So there are two things which can measure the combustibility of a fuel. What are the two things? One is flash point, the other one is fire point. Now, flash point, how will you understand? Flash point is that temperature, that is the lowest temperature at which the liquid is going to produce the vapor which is in sufficient quantity or in sufficient concentration so that it can be ignited by a small flame. Now, what is flash point? Flash point is a temperature. So, what is that temperature? It is the minimum lowest temperature at which if a particular liquid which you are using that as a fuel should be able to generate enough vapor and जितना इनफ वेपर आया हमको ताकि वो ऑक्सीजन एटमॉस्फेयर से कंबाइन हो सके और वो अच्छा क्लाउड फॉर्म हो बन सके, and that cloud, once it is ready, can easily be ignited, is what you need to understand. I hope flash point is very clear. Is flash point clear? Now, what is fire point now? We have understood anyway flash point. What is the difference between a flash point and a fire point? Now fire point is the temperature at which there is enough heat to cause combustion. That means what? कंबस्शन होने के लिए जितना टेम्परेचर हमको होना है एक फ्यूल के लिए उतना टेम्परेचर तो है, then that is called fire point. Now fire point is also a measure of temperature, and your flash point is also another measure of the combustibility. If you want to measure how combustible a particular fuel is, if you want to measure the combustibility, then two temperatures are very important for us. One temperature is talking about the flash point, and another temperature and another thing is talking about the fire point. The only difference is that when you talk of flash point, it is the lowest temperature at which at that particular temperature, if you heat the fuel, it should be able to generate enough vapor. Enough का मतलब क्या है इधर? Enough vapor का मतलब क्या है? What do you understand by enough vapor?
इग्नाइट करने के लिए.
Ignite करने के लिए इसका एक और मतलब है. Suppose that vapor concentration on account of fuel ignition, if suppose that concentration is too much when compared to oxygen. So whenever you talk of, you should talk of the combination only. If that ratio, let us say, if the ratio is now between oxygen and the vapor that is coming out now from the fuel, if the ratio is disproportionate, if it is not in the right proportion, then even then you don't get any combustion. That point you have to understand. So for example, if 10% oxygen instead of 21%, if suppose there is some insufficient oxygen, खाली 10% तक है, so 10% तक अगर oxygen है तो then it is the limit. So below that limit, if oxygen level is falling, then you cannot get a flame, you cannot get combustion. That is what you need to understand. That is what is meant by the enough. The word enough means that. Now the fire point also we have understood, flash point also we have understood. Now you need to understand what is known as flammable range also. What is flammable range? Flammable range is nothing but if you take the percentage of fuel that when mixed with air is needed to sustain combustion to be self-sustained. So once you external ignition you can bring only once, you cannot every time bring the external ignition. Once it is made to react with oxygen, that fire should sustain, that combustion should sustain. And what is the percentage of fuel that is required in order to make the fire sustain for a very long time? So that is called the flammable range. So flammable range is nothing but what is the percentage of fuel that is required which has to be mixed with the air in order to sustain the combustion. Combustion should prolong, it should not stop all of a sudden. Whenever there is a depletion of either fuel concentration or concentration of oxygen below a limit, you cannot sustain combustion, isn't it? So if you want the combustion to be sustainable, then what is required is enough concentration of vapor should be there, and at the same time enough concentration of oxygen should also be there. That means what? Both of them should be in right proportion of ratio. Only then you will see that they will be ready for flame. Otherwise they will not. Too much or too little of either fuel or oxygen, it will not be ideal for combustion at all. You will not see. That means too much or too little of any one of these, either the fuel or oxygen, is not ideal for combustion. Now hydrogen, why we said it is dangerous, means it has got a very wide flammable range. It has got a very wide flammable range, ranging from 4 to 7%, and it is very serious fire threat. So, but in contrast, gasoline or some kerosene if you take, the flammable range is 1 to 6% range. So that means it is a tolerable, safe range. That means. What will happen? Now carbon dioxide is denser, heavier than air, and then tends to settle, push air away. Now because it is heavier than the air. So what does it do? It is going to push whatever air that is there, and it is going to push that air, and it is going to occupy that space near the floor. Now, if suppose there is limited ventilation is not proper, all the doors are closed and your windows are closed. Now, carbon dioxide will displace the needed oxygen. Now, whatever oxygen that is there, it is going to replace that, and it is going to occupy, and the burning will be reduced, isn't it? When oxygen is now one of the supporters of fire, if it is depleted, if it is not there, and if it is replaced or displaced by carbon dioxide, then you see that there is slowing of burning. So that is the reason why carbon dioxide is acting as an extinguisher. You understood why, what is the concept of carbon, using carbon dioxide as one of the extinguishing element, fire extinguisher, why it is used? Did you understand the concept?
It replaces oxygen.
Now, why by replacing oxygen, what is the good thing that it is doing? Because we are trying to understand not fire promotion, fire suppression. We are trying to understand, extinguishing means what? Fire suppression, isn't it? So, in order to suppress fire, what is that? Either you have to eliminate the fuel or else the oxygen, because these are the two things which are responsible for fire, isn't it? So, in order to remove fire, what is that you have to do? Either remove fuel, one thing, or else remove the oxygen. These are the only two things. So, when you are removing oxygen, how are you removing oxygen? By introducing carbon dioxide. So, that is what you precisely do in carbon dioxide extinguisher. Now, you are trying to by pumping carbon dioxide, which is little heavier than air. So, air along with oxygen is also present in the air, isn't it? So, along with air, the oxygen in that is also getting displaced with what? Carbon dioxide. Now, that means what? Out of the two, you are completely removing the oxygen, isn't it? So, when completely oxygen is removed out of the two, now there is no question of combustion. Automatically the flame will be reduced and then fire will be put off. So, that is the principle involved in the using carbon dioxide as one of the fire extinguishers. Now, having understood this, I also told you that suppose people are there in the floor or in the ground, and let us say there is a very sizable fire is sizable, and there is not sufficient ventilation, let us say, because of the phenomena of carbon dioxide displacing oxygen. You see that people will die of suffocation. Though carbon dioxide is not that harmful compared to carbon monoxide, but yet because oxygen is now being completely, maybe it is good for the fire suppression, but then when people are there, then probably the carbon dioxide is also equally dangerous, because not per se carbon dioxide is harmful. The reason why it is harmful is it is replacing or displacing oxygen. That is the problem. Now, we also try to understand what is pyrolysis of the solid fuels and solid combustion. More complex, it is more complex when compared to the combustion of the liquid fuel. Then they will be converted into more and more volatile material, and wood does not vaporize quickly. This is a known phenomena. Wood or charcoal doesn't vaporize quickly, isn't it? And it will only above surface phenomena, pyrolysis, and then what we have to understand is it will happen exactly 1/4 above the surface. You will see this kind of a phenomena. Now, what exactly happens in pyrolysis is that solid materials are broken down into smaller molecules, and if suppose they are solid fuels, if they are suppose sufficiently heated, it will be, components will start breaking apart, and you see smaller formation of the molecules, and the advantage of breaking down into smaller molecules is that smaller molecules are easy to vaporize. So once the solid material breaks into smaller molecules, then these smaller molecules are very easy to vaporize, and hence there is a possibility that you can get a flame there. Now the burn patterns also, I think the manifestations of the burn patterns, then the spalling and all, these things, I think probably next class, tomorrow's class, will try to discuss. You know? So far, are you able to understand? Because I am not getting any responses. I am little afraid whether it has become too technical, whether you are able to understand it or not.
मैम टेक्निकल था लेकिन आया सब
समझ में आया था.
हाँ यस मैम
हाँ. So that, because these things we need to understand, because they are very important. Most of the time, only these type of questions will be asked from the event point of view. So that is the reason why I thought more than the patterns are very easy to understand. There is only one pattern, that is V pattern or inverted cone pattern. We have spalling, alligatory type of a formation is only these. Only 2-3 things are there. They are very easy to understand. But the other things like flash point, fire point, pyrolysis, ignition point, and all these are little smoldering, pyrolysis. These are little difficult to understand, thoda technically. इसलिए I thought I should today only concentrate on these things. I think I am able to make sense, है ना?
यस
ठीक है, we'll leave the meeting.